Today we're going to talk about 2010 AMC 10A Problem 12. Logan is constructing a scaled model of his town. The city's water tower stands 40 meters high, and the top portion is a sphere that holds 100,000 liters of water. Logan's miniature water tower holds 0.1 liters. How tall in meters should Logan make his tower? So in this problem, the most important part is that we know what the scale of the model is. So how do we figure out the scale of the model? Firstly, let's draw a graph to represent the water tower. So this is a sphere. Let's imagine that sphere, and then we have a stand for the water tower. So let's just assume that's the whole building. That's 40 meters high. And this is the ground, so that's perpendicular. And then we have this part, it has a volume of basically 100,000, so we can write that 100K, and it's 100K liters. So now we have all of our values, and we're gonna draw another water tower. This one represents the model Logan has. So this is a sphere, and this is the height, the stand. This part is also the ground, or it's the table wherever Logan put his model. So this part now only holds 0.1 liters of water. And we want to figure out the height. So let's call that small h. And we can call this height big H. So big H equals 40 meters. So now basically we want to use the information we already have, which is that we have the volume of the actual sphere is 100K liters, and the volume of the model sphere is 0.1 liters to figure out the scale. So firstly, we need the equation, the formula for the volume of a sphere. So the volume of a sphere its volume is 4/3 times pi r cubed. So basically, if we apply this to the 100K, then we have 100K. So let's just write that in numbers now. 100,000 equals 4/3 pi r cubed. So let's call this big R. Let's call the radius big R. And therefore, we also have 0.1 equals 4/3 pi small r cubed. Let's call the radius of the model small r. So now we've got the two portions, and we can just basically divide one equation by another. So we have 0.1 over 100,000 is basically 4/3 pi r cubed over 4/3 pi big R cubed. And luckily, we're really lucky. So these terms cancel out, and we're left with small r cubed over big R cubed is 0.1 over 100,000. So this means that basically 1/1,000,000 is the portion between r cubed, small r cubed, and big R cubed. If we take the cubical roots of both sides of the equation, then we get 1/10 to the power of 2 is the length of r, the small r and big R. So we have the proportion of lengths. So if we just plug 40 in for big R, if we just plug 40 in for this length here, then we have, so let's say the height of the water tower model is x, then we'd have x over 40 is 1/100. So therefore we have x is 40/100, which is 4/10, which is 0.4 meters. So we look back up and we see that there indeed is an answer choice of 0.4 meters, so we just select that. So this problem, there are a few key things to identify. Firstly, we need to know what exactly the length of the scale is. So, and in order to figure that out, we need the volume, we need the formula of the volume of the sphere, which is 4/3 pi r cubed. And basically after that we need to plug the scale into for 40 meters to figure out h. So thank you for watching. Remember to like, subscribe, and share, and also comment below so I can improve my future videos. Bye.